Hello, so this is Junior Mathematics Challenge 2015, question 6. What is the value of x in this triangle? And we have the various options there. So there are two concepts we need to consider for this question. First one is angles on a straight line sum to 180 degrees, which should allow you to see that this here is 60 and this here is 70. And secondly, angles in a triangle sum to 180 degrees. Therefore, 60 plus 70 plus x equals 180. X is therefore 50. B. So this is Junior Mathematics Challenge 2015, question 7. The question reads as, the result of the calculation 1, 2, 3, 4, 5, 6, 7, 8, 9 times 8 is almost the same as 9, 8, 7, 6, 5, 4, 3, 2, 1, except that two of the digits are in a different order. What is the sum of these digits? Now, at first glance, this looks like a scary question. They are massive numbers. How are we possibly going to be able to do this on such a quiz where we need to be quick? But we need to make a start. And we can do that by just considering the first or the last digit here. And we can immediately see that this digit, it ends in a 2, and that digit is out of order. And secondly, we can add in the next digit, which is 8 here. That will give us 640. And we've immediately got the two digits we require, therefore the sum of 1 and 2 is 3, and we're done. It's a question that looks scary at first sight, but very quickly becomes simple once you just approach and try the question. This is Junior Mathematics Challenge 2015, question 8. Which of the following has the same remainder when it is divided by 2 as when it is divided by 3? First, we know all the answers are odd, and any number that's divided by 2 that is odd will always have a remainder of 1. Therefore, we can remove any options that are directly divisible by 3. Then just simply consider, so this has remainder 2 when divided by 3. This has remainder 2 when divided by 3. This has remainder 1 when divided by 3. It's the only unique option. It must be this one. Check it. 2, 2, 2, 6, 1. Correct. So this is JMC. Question number 9. JMC 2015. According to a newspaper report, a 63-year-old man has rode around the world without leaving his living room. He clocked up 25,048 miles on a rowing machine that he received for his 50th birthday. Roughly how many miles per year has he rowed since he was given the machine? So how many years has there been since his 50th birthday? If he was 50, there'd be 0 years. If he was 51, there would be 1 year. There's 13 years. And he clocked up 25,000, roughly, miles on a rowing machine. How many miles per year did he therefore do? Well, if we can very roughly do 26, and I call it 26 just because look at the accuracy in the answers, we have enough room for that. And it's very easy to divide it by 13 because it's quite clearly 2,000. If this were 25, it would be a little less, but in order to be roughly 1,000, it would have to be 13, which is nowhere near. So the answer is most definitely 2,000. This is Junior Mathematics Challenge question 10 for the year 2015. In the expression 1 blank square 2 blank square 3 blank square 4, each square is to be replaced by either a plus or a times. What is the largest value of all the expressions that can be obtained in this way? So I think the key here is that multiplying something by 1 will always return the same value. So 1 times anything will always equal itself. But 1 plus anything will always be 1 more than anything. Therefore, the box in between 1 and 2 has to be a plus. And then I hope it's reasonably obvious that to get the largest, you're going to need to do multiplications there. In the remaining 2, from BODMAS, we do the multiplications first and then add on second. So 2 times 3 times 4 is the same as 2 times 12 is the same as 24. Add 1, 25. The answer is E.